So, hello everyone, welcome to another new session of AB's chemistry classes. In this session, we will discuss some super important topics of this chapter. So, watch the full session very carefully. So, let's start today's session. So, have you guys ever wondered how light travels crores of miles through vacuum at such a high speed, and how light travels through vacuum? Isn't this question amusing? So this question also amused the ancient scientists, but they didn't have any kind of explanation in this regard. The first explanation was given by Sir Isaac Newton in his corpuscular theory. In corpuscular theory, light was considered to be consisted with some corpuscle. Corpuscles are tiny balls with zero mass, right? So in this theory, light was considered to be a particle. With this consideration, Newton was able to explain the reflection and refraction of light. But this theory falls short to explain the diffraction, interference, such kind of phenomenon. To explain such kind of phenomenon, Young put forward the wave nature of light. So in this regard, it has to be mentioned that much before than Young, Huygens actually given the wave nature of light. But at that time, Newton's corpuscular theory was so popular that people rejected Huygens' theory. After Young, James Clerk Maxwell made some remarkable improvement in this theory. Maxwell explained how light is generated, how it travels through vacuum, and all that phenomenon. And that theory was also able to explain all the behaviors of light. Okay. So let's see what are Maxwell's electromagnetic theory. In 1838, Faraday proved that a changing magnetic field can produce an electric field. Okay. But till then, it was not known whether a changing electric field can also produce a magnetic field or not. This was proved by Maxwell. Maxwell proved that as changing magnetic field can produce electric field, also changing electric field can produce a magnetic field. Now, based on these discoveries, Maxwell told that when transverse electric and magnetic field oscillates, then electromagnetic radiation is generated. Okay, so when transverse electric and magnetic field oscillates, then electromagnetic radiation generates. And also the direction of propagation of the magnetic field is perpendicular to the direction of oscillation of electric or magnetic field. That means if electric field is oscillating like this and magnetic field is oscillating like this, then the direction of propagation of light will be in the forward direction, right? So that's it. He also told that all these things, that is generation of electromagnetic radiation, is a continuous process. For any student of class 11, this is all. But who are preparing for JEE or NEET, they need to learn little more. You who are preparing for NEET or JEE, they already know that how an electric field is produced or how a magnetic field is produced, right? You guys already know that a oscillating charged particle produces an electric field, and then oscillating electric field produces a magnetic field, right? You know this. Now this electric field and magnetic field together produces a electromagnetic radiation. Now to produce electromagnetic radiation, the oscillation of electric and magnetic field is necessary, and to generate an electric field, a charged particle is necessary. Now tell me, in the vacuum, where is that charged particle that is developing the electric field, and the electromagnetic radiation travels through the vacuum? So there is no charged particle, right? So who is creating the electric and magnetic field in the vacuum then? That's the question, obvious question, right? Now you have read Lenz's law, right? What Lenz's law says? Lenz's law says that when a electric field generates a magnetic field, the magnetic field will repel the electric field. Okay, now let's see, this is two perpendicular planes. Okay, now if electric field is generating in this way, then a magnetic field will be produced in the perpendicular direction. Now this magnetic field will repel this electric field, and we will try to minimize this electric field. To minimize this electric field, what happens? A electric field in the negative direction of this field is upward. Then this magnetic field will repel this electric field, and will try to minimize this electric field, and for that reason it will create electric field in the opposite direction, in this way, direction of which is the backward direction, and this electric field will also generate a magnetic field in this manner. So this process will continue throughout the path of the travel of the electromagnetic radiation. So there is no need of a charged particle to generate this electric and magnetic field simultaneously. So in this way light will travel through the vacuum, and the presence of any particle wouldn't be necessary. Okay, this was Maxwell's electromagnetic theory. Now the question is, according to Maxwell's theory, any electromagnetic radiation will be produced when transverse electric and magnetic field oscillates. Now how can we distinguish between two electromagnetic radiations? According to Maxwell, the difference between two electromagnetic radiation will be in its wavelength or frequency. Now what are those? Okay. Let's understand some important terminologies of an electromagnetic radiation. The first one is wavelength. What is wavelength? In Maxwell's electromagnetic theory, any electromagnetic radiation is considered to be a wave, right? So it will propagate in this manner, right? So in the propagation of wave there will be some peaks and some trough. Okay, the distance between two peaks is known as wavelength. It is represented as lambda. So you can understand that wavelength represents a length, right, a distance. So the unit of wavelength in CGS will be centimeter, or in SI it will be meter. Now the next terminology is frequency. Frequency. What is frequency? Frequency is the number of waves that passes through a particular point in 1 second time interval, that is frequency. So through a particular point a number of waves passes in 1 second time is called frequency. Frequency is represented as nu, and its unit is cycles per second, or CPS, or hertz. Now next terminology is wave number. What is wave number? The number of total waves that are present in unit distance is called wave number. So let's consider this is our unit distance. Okay, through this this kind of wave passes, okay, through this unit distance. This is the wave in this unit distance. Now total number of wave is from this peak to this peak, that is 1. From this peak to this peak, this is 1, and from this peak to this peak, this is another 1. So wave number is 3. So in this unit distance the wave number of 3. So wave number is represented as nu bar. Nu bar is equal to 1 by unit distance, that is 1, divided by what? Number of divided by what is this? Wavelength divided by lambda. So its unit will be in CGS, centimeter inverse, and in SI it will be meter inverse. Based on the different wavelengths and frequencies, the full range electromagnetic waves can be divided into some categories. They are: number 1, radio wave. Number 2 is microwave. Number 3 is infrared. Number 4 is visible. 5 is ultraviolet. Number 6 is X-ray. 7 is gamma ray. Okay. In this direction, wavelength decreases, frequency increases, and energy increases. Okay, so these are the kind of waves that we know till today. So these are the kind of waves that we know till today. Now this electromagnetic theory of Maxwell was able to explain the facts like reflection, refraction, diffraction, interference, but it was unable to explain the blackbody radiation. Now what is a blackbody? Let's first know. Blackbody is a substance that accepts all kind of radiation that falls upon it. Also, blackbody can emit certain radiation. When the radiation emitted from a blackbody was plotted against a wavelength, it was found that the graph is in this manner. Intensity against wavelength. What we can see from this graph, we can see that in blackbody radiation of certain wavelength is at maximum intensity, and radiation to the wavelength lower or higher to that wavelength is much lower intensity, right? So here is intensity low, here also intensity is low. Radiation at a particular wavelength has maximum intensity, and this wavelength is called lambda max. Many scientists, considering the classical electromagnetic theory of Maxwell, tried to explain the blackbody radiation, but their theoretical graph of blackbody radiation was in this manner. So they were unable to explain the actual graph of a blackbody radiation. To explain the actual blackbody radiation curve, Max Planck, from a German scientist, put forward his quantum theory. Planck's quantum theory. Now this Planck's quantum theory is very much important because this theory changed the whole dynamics, whole point of view of physics and chemistry. So let's understand what is Planck's quantum theory. In his quantum theory, Planck considered that the absorption and emission of electromagnetic radiation is not a continuous process. Okay, till that time it was known that all these processes are continuous from Maxwell's theory, but he first told that this is not a continuous process. But then what it is, right? He told that the absorption and emission of energy by substance always occurs in some small packets of energy. Okay, and the total energy is the integral multiple of that small packet of energy, and that small packet is called a quanta, and for light it is called photon. Quantum is the plural form of quanta. Okay, so you have seen stairs, and you have also seen ramps. In stairs, in either can be in stair 1 or 2 or 3 or 4, but you can never be in between these two stairs, right? Now whereas in ramps you can be anywhere on this ramp, at any point. So this ramp is a continuous thing, and the steps are discrete thing. Now if we consider the stairs as energy levels, so first energy level, second energy level, third, fourth and fifth, the energy difference between these first two steps, E1 minus E2, is called let's consider it as epsilon. It is the quanta. If this is the quanta, then E3 minus E1 will be 2 epsilon, E4 minus E1 will be 3 epsilon. So total energy of a system will be integral multiple of some small amount of energy. That small amount of energy is called a quanta. Now he considered that this energy, this small energy, will be proportional to the frequency of the radiation. So epsilon is proportional to frequency nu, or epsilon is equal to h into nu. This h is called Planck's constant. The value of Planck's constant is h is equal to 6.626 in 10 to the power minus 27 arc second, or in SI it will be 6.626 in 10 to the power minus 34 joule second. So this is Planck's quantum theory. Okay, so that's all for today's session. If you like the video, then do press the like button, also the subscribe button along with the bell icon. So see you in the next session. Till then, stay home, stay safe, and always put your mask on.